So today we're going to go over the second part of chapter 7.3 notes, where we're going to do molar mass conversions. For type A, we're going to go from moles in the problem and change them to grams. So for example, what is the mass in grams, we're looking for grams, of 3.5 moles of oxygen? This is our given. So we're going to start by writing the given, 3.5 moles over 1. And we're going to convert, so that means we need a conversion factor where moles go on the bottom and the unit we're looking for, grams, goes on top. This grams per mole is the molar mass, and the grams go on top. So for oxygen gas, that's kind of a tricky question. The formula is O2. Oxygen has a mass of 16, which we find on the periodic table, and there are 2 of them. So the molar mass of oxygen is 32. Okay, so 32 grams of oxygen are in 1 mole. That's its molar mass. And now you can see moles cancel, and we're going to be left with the units we want, which is grams. And the answer is 112 grams of O2. For part B, now we're going to start with grams and convert 2 moles. So I'm going to write my given, which is 250 grams over 1. Okay, and then we have our conversion factor, but this time we start with grams, so I'm going to do the inverse of the molar mass, where grams are going to go on the bottom. Okay, so they cancel out, and per mole means the mole is going to go up top. The molar mass for glucose is 180.18, so 250 divided by 180.18 is 1.3875 moles. There are 2 sig figs in my starting number, so my answer needs to be rounded here. Since the 8 is greater than 5, that means we're going to round up to 1.4 moles of glucose. Okay, and we did not round this one off. This one should be rounded to 2 sig figs as well, since we started with 2. That is approximately 110 grams. For C, we're going to start with moles, but now we're going to change it to molecules. And the number of molecules in 1 mole, remember, is Avogadro's number, which is 6.022 times 10 to the 23rd power. That's how many molecules equals 1 mole. Start with the given, which is 5.0 moles over 1. And we're going to want moles on the bottom of our conversion factor. And we're trying to find molecules, so those go up top. Okay, and again, the number of molecules per mole is Avogadro's number. Okay, and so that is going to give us an answer of about 3.0 times 10 to the 24th molecules of copper 1 sulfide. That's Cu2S. Okay, for part D, we are going to start with molecules and change them to moles. So you can see our given is a very large number since it's in molecules, and molecules are tiny. We need a lot of them. Okay, since it's to the 25th power, I can tell it's going to be more than 1 mole because that's bigger than Avogadro's number. And I'm going to put molecules on the bottom so it cancels out, and 1 mole up top. Again, there's 6.022 times 10 to the 23rd molecules per mole. And now all we have left to do is take 4.8 times 10 to the 25th and divide by 6.022 times 10 to the 23rd. And we will get 79 36.7 moles of CuSO4. And since I started with 2 sig figs, I'm going to need to round my answer to 2 sig figs. The 7 is going to round up. 80 only has 1 sig fig. So to fix that problem and show that there are 2 significant figures, I'm going to put a decimal with nothing after. That's how many moles of CuSO4 we have. Okay, and last but not least, if we start with grams like we did up at the beginning, and we want to get all the way to molecules, every molecule has a different mass, so we have to first change to moles before we can find molecules. So let's start by writing our given in grams, 36.0 grams over 1. And our conversion factor, you're going to see we want grams on the bottom and moles on the top. And the grams per mole for water is 18.02. You can look that up on the periodic table. That's how many grams are in 1 mole. Then we need to still change from moles to molecules. So we're going to have moles on the bottom. 1 mole of water is 6.022 times 10 to the 23rd molecules. And so if we want to know how many molecules are in those 36 grams, we're going to take 36 divided by 18 and multiply that by Avogadro's number. And we get 1.20 times 10 to the 24th molecules of H2O. Okay, so that's the number of molecules. Don't forget when you're entering Avogadro's number or the number of molecules and you have an exponent, that you must, on the calculator, find the appropriate button for exponents. That often is capital E, capital E. Sometimes it's written as EXP for exponent, and sometimes you'll have a specific button that says times 10 to the n or times 10 to the x. So use the correct button on your calculator when you're doing these calculations. Last but not least, a way to remember if we're multiplying or dividing is called the valley of the moles, where moles are in the valley at the bottom. Molecules or units are on the right, and grams are up on the left. Okay, and remember when you go down into the valley, you're going to divide by the molar mass. So that means that the grams should appear on the bottom, just like they did right here in the previous problem. If you go up out of the valley, you're going to multiply. On the right, we're multiplying by Avogadro's number, which is Na. And if we go down, we do the opposite. We're going to divide by Na. Okay, and then over here, if we're going from moles up to grams, we are going to be multiplying by the molar mass. All right, that is it for mole conversions. We'll finish the next part in the next video. Have a great day.